Good morning everyone. Last time we did epoxidation of alkene and today we are going to discuss ozonolysis, which is very important reaction. So let's start ozonolysis. So this ozonolysis is of two type. The one is oxidative and the second one is a reductive ozonolysis. Reductive ozonolysis. So if you are going to talk about the reagent of oxidative and reductive, so look at here. Here in oxidative we are using O3 with H2O2, and in reductive reagent is O3 zinc H2O or O3 DMS dimethyl sulfide. Okay, structure is like this: dimethyl sulfide. So any one of them will be in reductive and H2O2 will be oxidative one. So let's talk about the very first reductive one. Only one difference in reductive and oxidative. Look at here. In oxidative ozonolysis, if you have aldehyde, then aldehyde further oxidized to give you acid. While in reductive, aldehyde remains aldehyde and ketone remains ketone. So let's start this one. Suppose we have this alkene, a very simple one, CH3CH double bond CH2, and we are going to treat them with O3 zinc H2O. So zinc is a reducing agent and we are doing reductive ozonolysis. So the key point is here, break the double bond and attach oxygen on both sides of carbon. So if you look at the left hand side, it will be RCHO and it will be CH2O. If you are going to expand this RCHO, it will be like this. RCHO is like this. While this one, carbon double bond oxygen, left hand side a hydrogen and right hand side is a hydrogen. So these two are the product of reductive ozonolysis. Suppose we have a same reaction but we are going to use oxidative one like this, O3H2O2. So we have this again RCHO plus this is again C double bond OH. Clear? In this case we both have aldehyde, both molecules are aldehyde and we are using oxidative ozonolysis. So both is going to oxidize and it will be acid. So it will be C double bond OOH and this one will form formic acid. Formic acid formula is HC double bond OH. So this one is a oxidative and right one is a reductive ozonolysis. Let's discuss another example. Suppose we have this molecule and here we are using O3 zinc H2O. So what will happen? So you can break this bond and attach oxygen on both sides. So the best way to draw the product is always mark numbering. This carbon supposed to be your 1 and this carbon is supposed to be 2. So look at the carbon number 1. It will be like this, double bond O. And if you balance, this is methyl. This one is also methyl. So this is methyl and this one is a methyl. And the right one, this is CH3, and if you balance, there is a one hydrogen as well here. So one more product, and look at the number 2 carbon. Number 2 carbon has a double bond oxygen. One side is a methyl and one side is a hydrogen. Clear? So this is a reductive ozonolysis, and suppose we are going to discuss oxidative one, O3, H2O2. So first step is quite same, CH3, CH3, and this one is CH3CHO. You can see this is aldehyde. So aldehyde further oxidized to give you acid. So CH3C double bond OH. So these two are the final product. One is a ketone molecule and one is a acid in oxidative ozonolysis. Sometimes we have a ring, suppose this one. Most of the student has issue with the ring type questions in ozonolysis. So look at here, it's quite simple. So whenever you have a ring, always mark the numbering. The best way is to mark the numbering on each carbon. So look at here, 1, 2, 3, 4, 5, 6. Break the 1,6 double bond and attach oxygen on both sides, oxygen here and oxygen here. So look at here, this is a ring. Once you're going to break, it will be open chain. So we can start from carbon number 1. So suppose this is carbon number 1. One has a methyl, one has a methyl. And this one has a double bond oxygen as well, double bond oxygen. Now one is bonded to 2, 2 bonded to 3, 3 bonded to 4, 4 bonded to 5, and 5 bonded to 6. And you can see 6, there is a double bond oxygen, and here we have a hydrogen. Clear? And in the last you can delete the numbering as well. So this is very simple, just mark the numbering and then attach in the same way. So you can see 1 mole is my ketone and another mole is aldehyde. Clear? If suppose this reaction is like oxidative one, O3, and here we have H2O2. So we can copy the same product, but this is aldehyde. So aldehyde becomes acid in oxidative one, but this ketone remains same. So look at here, this is number 1, double bond O, CH3, 2, 3, 4, 5, and this 6 will be double bond O, OH. Clear? Very easy. So this is oxidative and reductive ozonolysis. Suppose we have this one, multiple double bonds. Okay. And if you want to keep a double bond here as well, no problem. So we are going to do O3 zinc H2O. I said always mark the numbering. Suppose 1, 2, 3, 4, 5, 6, and you can say this one as 7 and this one is 8. Clear? Now all the double bonds we have to break. So this is going to break oxygen, oxygen. This is going to break oxygen, oxygen, and this is going to break oxygen and oxygen. So now look at any of the parts. Suppose we are going to check 4, 5 and 6 connectivity. So this is 4, 4 bonded to 5, 5 bonded to 6. 6 has double bond O and there is a hydrogen. This side also has double bond O and a hydrogen. So this is 4, 5, 6 component. Now look at the 3, 2, 1. Okay. So 3 bonded to 2, bonded to 1, and 1 again bonded to 7. So this is 7. Now look at 3 has a double bond oxygen with a hydrogen. 1 has double bond O. And 7 has double bond O with hydrogen. Clear? And now the last one is what? The eighth one. This is a carbon having two hydrogen. So a carbon having two hydrogen, this is number 8 carbon. And we have a double bond oxygen. So you can see, it's very simple. Whenever you have multiple double bond, always mark the numbering and then split all the double bonds and attach oxygen in both the side. Retroozonolysis is also very important. Retroozonolysis. What is retroozonolysis? Suppose we have a product like this. This one. So simple thing is that you have to copy the same product one like this. And remove the oxygen and attach both. Remove the oxygen and attach both. So this is the alkene. Clear? And if you want to cross check your answer, you can break the double bond and attach oxygen on both sides. You will get the same product. Clear? So it's very simple. Suppose we have this one. Suppose this CHO. So 1 mole is this one and 1 mole is CH3CHCHO. So look at, the first job is to keep both oxygen in same phase like this. And CHO, so CHO like this. CHO bonded to CH. CH has 2 methyl. And now remove the oxygen of both and just connect them. So ring, double bond, CH, and then CH is bonded to another CH, dimethyl like this. Clear? So this is all about the ozonolysis, and it's very, very important, because in the next chapter, once we are going to move in the enolate chemistry, you can see if you have a both mole of aldehyde or ketone, then we can use them in aldol condensation. So they can start with the alkene. First they will draw the ozonolysis like this. I can give you a question in this way. Suppose we have this alkene and then we are going to start with O3 zinc H2O. This is unknown product A, and then A is treated with dilute NaOH. Clear? So the first step is what? Reductive ozonolysis. So you have to break this and attach oxygen on both sides. So you have this product, ketone and this aldehyde. And now we have 2 mole of carbonyl. We are using NaOH as a base. So the reaction is aldol. So in aldol, we will discuss in the next chapter, but here I can tell you. So any one alpha hydrogen you can remove, means you have to remove 2 alpha hydrogen and this oxygen and just connect them. Simply in this way. If you are using heat as well, then condensation. So look at the answer here. C double bond O. This CH3 we can say in this way. And this is CH3. And here double bond O, carbon, H and H. So 2 alpha hydrogen, this is alpha carbon, 2 alpha hydrogen and this oxygen. So there is a loss of water. And then you can see here CH3COCH. So CH3COCH, and this CH is bonded to double bond CH2. Clear? So this is alpha and this is beta. So this is alpha beta unsaturated carbonyl, which is a product of aldol condensation. And don't worry, we will discuss aldol in detail in enolate chemistry. So this is just application of ozonolysis. Once you have ozonolysis, you have a multiple products, and we can use these products as a reactant component in aldol and multiple reactions as well. We can use some reducing agents like LiLH4, NABH4 to reduce these aldehyde and ketones. So this is the organic route. And if you watched this video, please copy down everything in your notes and revise like every alternate days. So thank you so much for watching this.